This video is sponsored by sceneXplain, the leading image-to-text platform. What will happen when autonomous AI agent got GPT-4 vision power? It will allow us to build front-end agent. It can continuously iterating and improve the web design, answer complex questions that are not possible to be answered today, and even power general-purpose robots where it can make plan and take actions based on the camera image it is taken. We saw lots of people start experimenting with chatgpt vision, but it wasn't clear what the boundaries are, what kind of image tasks that it is doing really well today, and what are the ones that's not, and how is prompting a multimodal model like GPT-4v different from other large language model that we have been using that only takes text. But Microsoft released a research paper that answered exactly those questions, where they tested hundreds of different image tasks with GPT-4v to understand what it is actually good at and what it is not, and also introduce some new prompting tactics. I will break this down for you so that you can understand what it is good at, what it is not, and how you can improve. And in the end, I'm going to show you a case study about how can you build an autonomous AI agent with vision ability today. Using autogen, stable diffusion, and Llava model, they can continuously self-improve AI-generated image. So let's get it. Firstly, let's talk about what's the real power of multimodal large language model. And if you don't know what multimodal is, here is a quick explanation. The large language model that we have been using today only takes text input. It will take large amount of text data into vector, so that next time when someone prompting new text, it will start predicting the next words based on the vector space. A multimodal model, on the other hand, takes not only just text data, but also image, audio, and even video. Behind the scenes, it will try to tokenize all the different type of data and create a joint embedding so that it will understand this three type of data, even though they are different formats, they are similar information. And this unlocks some pretty crazy capabilities. For example, if you give the model an image of a park as well as the audio of dog barking, it can return an image that is relevant to this scenario. And if you give an image of your fridge, it will be able to identify what the items are and also come up a menu for it. So this definitely opens up lots of new use cases. And the one that GPT-4v's unlock is the text plus image. GPT-4v can handle loads of different image types. It can easily understand a photograph, but it can also understand the text within the image very well, even though some of texts are distorted and hard to see, like ones in those examples. It can also understand formulas, table, diagram, and even floor plan. And this is particularly exciting to me because there are tons of data that couldn't be easily digitized and communicated to AI at the moment, as many of the company's knowledge base are PDF files like diagram and charts. And the part that I found most surprising is you can actually pass GPT-4v a few pages of documents. Like in this example, they actually feed GPT-4v 6 pages of a research paper, and the GPT-4v actually summarized the whole research paper really well. I'm pretty curious to understand how does this work behind the scenes. Does GPT-4v actually extract all the text data across pages and then to understand it, or it is doing something different? Because this might help us build better retrieval system. And on the other hand, GPT-4v not only just extract data from image, it actually understands those images. For example, it can recognize in this image, the person is Biden. And on the right side, this is CEO of NVIDIA presenting a new product from NVIDIA, very likely to be a new GPU. Same kind of recognition ability has been demonstrated across landmark, food, brands, and logos, even though some of the logos are presented in distorted way. On the other hand, it can do tasks like counting the number of objects in the image, and even do the reasoning. If you ask this question, is the person bigger than the car from this image? It will know that it is not because of the distance and perspectives. So the overall out-of-box performance is really impressive, but it also makes tons of mistakes. For example, when we ask GPT-4v to extract data from this ID, it gets everything right except hair is brown. And if you present a chart like this and ask it which year has the highest average gas price, it will give you the wrong answer. And it has a lot of trouble to understand the speed meter for some reason, and when it is doing the objects counting tasks. If the items is cut off, it can give you wrong answers as well. And what's interesting here, they actually try some common prompting tactics that we have been using, like let's think step by step. But for some reason, this doesn't seem to impact image tasks much. Even though it breaks down tasks, it still gives the wrong answers. But here are some prompting techniques that they tried and worked really well. But before we talk about prompting techniques, I want to introduce you to sceneXplain. While you might not have access to GPT-4v yet, sceneXplain is a great alternative that you can use it today. They provide a powerful multimodal model that can do a wide range of different image tasks. It can turn image to a fully fleshed out story or doing question and answer on images. And they also fine-tune the performance for specific image tasks like extract JSON from image. This allows me to upload thousands of product images and tell the model about specific information that I want to extract, like product color, brand name, material, texture, and keywords. So from this example, it is able to tell that this is an earphone. The color is black and the brand name is Sync Plus. And they can work with not only image, but also videos. For example, I can upload this video clip from Dunkirk, and it is able to give me the full story, even though this video has no script at all, because the model actually breaks down the video into different frames and understand the image of each single frame. This is a very unique ability that I haven't seen on any other platforms. You can try out their model today, either through their web UI or use the API endpoint to build vision-powered AI apps. On the other side, you can also access it through the ChatGPT plugin by pasting an image or video URL and have multi-modal ability in ChatGPT. They provide free credits for you to use, and if you decide to get more credits, you can use my code AIJSON to get 15% off for the first month. Thanks again for sceneXplain sponsoring this video. Now, back to visual prompting techniques. The first is text instructions. Even though when we ask it to think step by step, it doesn't really work well, but when you give it very specific text instruction, it does help improve the performance. For example, in this specific task, it gives the text instruction to firstly explain the image and the structure. This is image in a 2x2 matrix. And then it gives specific steps about how this image task should be done. Look at first column to understand the pattern, and then look at the second column to guess the missing image here. And this returns the right answer. So this is a first prompting techniques that you can add in detailed text instructions that explain the image and structure, so GPT-4v has more context, and then tell it the steps to complete this task. But sometimes just text instruction is not enough. In this object counting example, it still gets things wrong, even though you give very specific step instructions for the counting task. And this is where they introduce the second prompting techniques, condition on good performance. At default, GPT-4v only has a goal to complete task, but it doesn't have a goal to complete task well. So you need to explicitly tell it the expectation. They add two parts to the prompting. Firstly, they tell GPT-4v that you are an expert on counting things in image. And in the end, to be sure we have the right answer. With these two things, it set up the expectation better to guardrail the behavior. However, just these two things are not enough. It still gets things wrong for complex tasks like reading charts or reading the speed meters. No matter how many details you add into the prompts, it still gets things wrong. I got the same experience. I tried to get it extract text from a receipt, and no matter how many details I add into the prompt, it just gets things wrong. And this is where the third and probably the most powerful prompting techniques come in, which is few short prompts. We have been doing this with other large language model where we will give a few examples of how this task should be done so that the large language model can follow. And same thing applies for multi-modal model as well. For speed meter reading tasks, they try to give you examples. This is the first image and this answer. And now let's try to extract data from the second image. And what they found is with just one shot, it still gets things wrong. But when it provides GPT-4v with two examples, it starts showing much better performance and gets things right. And same thing happened for the chart reading example. When they just present one example, it still gets things wrong. But when you present two examples, the performance just starts increasing dramatically. I found this particularly exciting because this will allow us to fine-tune the GPT-4v with very low cost for specific image tasks. For example, any manufacturer can build your own defect detect system with some training data, and same thing for the medical diagnosis as well. So you can train GPT-4v to do very specific image tasks, no matter how niche it is. And the fourth prompting techniques is what they call visual referring prompting. This demonstrates GPT-4v's ability to understand visual annotation. You can have those arrows and circles, and GPT-4v will be able to understand which object you were talking about. The green pointer here actually points to both the floor, the desk, as well as the bottle. But it is able to understand the main thing here is actually the bottle. And this is also super exciting because they will unlock a new type of interaction that wasn't possible before. In future, people can just simply circle or point into something, and GPT-4v will be able to understand. A very simple use case is this could be used for customer support, where a customer can just simply circle on an area that they don't really understand. AI assistant will be able to help. So those are a few prompting techniques that you can use to improve the GPT-4v performance. But GPT-4v's power don't just stop there. It shows exceptional ability to take multiple image input, and it is able to understand the relationship between images. For example, if you presented two images, one is the menu with a price tag, another is the image of the table with food. It is able to understand and calculate how much money you will need to pay for the things you order. And this is another example that I found particularly interesting. They present 3 screenshots from a video clip of Big Bang and ask if the task is opening a door, what will be the order of the image? And it will tell you it is A, B, C. But if the task is closing a door, it is able to tell you the order is just the other way around. And this is another example where it presents GPT-4v 3 separate images and asks GPT-4v to understand the relationship between these 4 and try to assemble it. It is able to do it properly like this. And to be honest, this is a task that even me as a human will take a while to understand. And you can also send image of different people and tell you the name of each person, then present it a new photo. And it will be able to understand that this photo just includes 3 of the person that has been given and what's their names as well. And also able to transcript a video that don't have any script because it can understand the image as well as interpret what the person is doing based on a sequence of images. So this is GPT-4v. With all those amazing capabilities, I think it unlocks a few very exciting use cases. One is we can finally build real knowledge base for certain industry like architecture, engineering, manufacturing. And on the other hand, because its ability to understand the image and video data, I think this will enable search across multiple different types of data. For example, as a brand, I can simply search what are the videos my brand logo has been presented. And on the other hand, with things like future prompt, you can totally build defect detecting system as well as the medical diagnosis as well. But the part I'm most excited about is the agent ability. For example, we can actually get GPT-4v to critique the image generated from Stable Diffusion and then give feedback about how to improve. This can create an agent that continuously improve the image generation result. And on the other side, they also showcase a very interesting example for some kind of desktop automation. They give GPT-4v a task to go find a detailed recipient of mapo tofu, and GPT-4v will be able to complete a serious task. Open Chrome first, search in Google, get the first results, click on a jump to receipt button, and then try to print out this receipt and get the final receipt. And same thing could be huge for robot as well. They simulate a robot task where it gives a robot a camera image in the living room and asks it to go to the kitchen and get something from fridge. It will be able to tell that I need to turn right to move towards hallway first. And when presented a new image, it will again find the path until it finds the fridge. If it's a real robot, then it can trigger action to open the fridge as well. So I think this really unlocks tons of use cases for agents. And I want to show you a quick example of how can we build an agent with vision ability today. Use image generation as an example. So I'll create an agent system that it will continuously improve the results of Stable Diffusion image generation by having one text-to-image engineer and one AI image analyzer with autogen, Stable Diffusion, and Llava. Because we don't have access to GPT-4v API endpoint yet, I'm going to use Llava as an alternative. And if you don't know what Llava is, it is another multimodal model that is based on Llama 2. It is not as good as GPT-4v, but good enough for us to build this proof of concept. I actually made videos for both autogen and Llava model, so you can check them out if you want to learn more. And in terms of Llava and Stable Diffusion model, I will be using the hosted version on Replicate. So Replicate is a platform that allows people to host their own AI models. Their pricing is a lot higher than other hosting platforms like Hugging Face or RunPod, but they do provide free credits. So it's very easy to getting started if you want to build a proof of concept or your volume is low. But if your volume became really big, I definitely recommend to deploy your own model on RunPod. So let's get started. I will use Visual Studio Code to implement this agent. So let's create a new folder and I will open the terminal to install both autogen and replicate if you haven't yet. So we'll do pip install py-autogen and replicate and click enter. And once you finish, also making sure you go to replicate under Llava 13b model, the API tab, and copy this code to import your replicate API into your terminal here. And once you finish, let's create one file called openai config list. So this is where you will import your OpenAI API key. It will look something like this with array, and inside will be JSON, model, and API key here. And next, let's create a Python file called app.py. And we will first import a list of libraries that we're going to use, and then import your OpenAI API key here to config list and create large language model config. And if you are not familiar with autogen, at high level, it is frameworks that allow you to create a multi-agent system. So in our case, I will need to create a group chat of 2 different agents. One should be doing image generation and have access to Stable Diffusion, and another should be doing the image analyze and give feedback about how to improve the prompt with access to Llava model. And the way we will implement this is I will create a function to use Llava model to review the image and give feedback about how to improve the prompt. And second is I will also have another function to use stable diffusion model to generate image. And then after that, we will create that two different agents and create a group chat to start the conversation. So firstly, we use Llava model. So the function is pretty straightforward because we simply use the replicate API endpoint. So this function will have two inputs. One is the file path of the image that it needs to be analyzed, as well as the original image prompt. So I will do replicate.run with a URL to this Llava model and two inputs. One is the image file as well as a prompt. What is happening in the image from scale 1 to 10, describe how similar the image is to the original text prompt. And then we'll return the results. And we can quickly test this. So I will create an image folder. And inside image folder, I will put in an example image. And inside app.py, I will call this image review function, pass on image file path, as well as prompt a paired driving car, and try to print the results. So I can save this, open terminal, and then run Python app.py. Okay, cool. So we get these results. The large language model is giving a rating 3 out of 10 in terms of similarity, because even though we have parrot, it is not really driving the car. So this is pretty good. We can use this as feedback to the prompt engineer to generate a new image. So the next thing is I will delete this too and create a new function for text to image generation with the input prompt. And again, I will use replicate with their stable diffusion model with input is prompt. And once we get the results, I will try to get the image URL first, and then try to download this image to my local computer and give a file name with the current date and also a shortened prompt, because sometimes prompt can be really long. So I want to making sure it's maximum 50 characters and save this image under this image folder. So I will do request.get with image URL. So this should return the image file. And once we get the results, I will save this file to my local machine. And I'll try again as well to calling this function text to image generation a rabbit in a hat and do Python app.py. Okay, great. So it returned this results of image URL and also a new image in the folder, a rabbit in a hat. This is actually a great example that this rabbit is not in a hat, but is wearing a hat. So now we have the core functionality. The next, we simply need to stitch them together with the agent. So I will create a new large language model config for assistants, because the assistant will need to have access to those functions we define with openai function calling. I will create a JSON file with function, and inside the array, I will have this two functions defined. One is text to image generation. Use the latest AI model to generate image based on prompt, return the file path of the image generated. And the input will be prompt. Description will be a great text to image prompt that describes the image. And same thing for image review as well. So it will review, critique the AI generated image based on original prompt and decide how can image and prompt to be improved. And inside here, I will have two inputs. One is the prompt itself as well as the image path. And in the end, I will do the config list and request timeout 120. And after that, I will create the two agents. One is a text to image prompt expert. So you are a text to image AI model expert. You will use text to image generation function to generate image with prompt provided and also improve the prompt based on the feedback provided until the similarity is 10 out of 10 with large language model config equal to the new config that we created and function map. And same thing for the critique assistant. So the name is image critique. You are a AI image critique. You will be using image review function to review the image generated by text to image prompt expert against the original prompt and provide feedback on how to improve the prompt. Give the large language model config assistance and function map. And after that, I will create a user proxy agent. And if you don't know what a user proxy agent is, that basically represents the user, which is you, in this group chat. So that when you have feedback or when the agent needs help, you have a way to provide feedback. And after that, I will create a group chat, which is like chat room for all those agents that you just created. And I will set max run equal to 50. So it can run this iterative loop for a couple of times. And then I'll create a group chat manager with this group chat, and I'll trigger a message to the manager. Generate a photorealistic image of llama driving a car. And I will do python.py. Okay, so firstly, it send out this message and the prompt engineer try to use text to image generation with this prompt. Okay, and once it's finished, you can see this is the first image it generated. The image critique agent start triggering the image review with both image path and this original prompt. And then it returns the response that it will rate similarity 7 out of 10. Because while the image does have a llama in the car, it is not photorealistic and the llama is not really driving the car. So the prompt engineer tried again with a new prompt and it generates a new image like this. Well, the llama is actually inside the car. And again, the image critique start reviewing. But for some reason, he thinks this image represents 10 out of 10 for llama driving a car. But what's good about autogen is it will actually get back to the user proxy, which is me, and ask me for providing feedback. So here I tell the agents, the llama is not really driving. It should has its palm on the steering wheel. So it go back to the prompt engineer and it generate a new image of this one. So our code is pretty good. It has exactly the llama inside the car in a position, and it has its palm on the steering wheel. If I want, I can actually continue get it going and iterating the image. So this is one quick example of how to build an agent with vision capability. And there are a lot more different types of agents you can actually start building now. I'm also interested to do a version of agent that can do more sophisticated tasks like browser automation. So please comment below about what type of AI agents that you want to see me building. I will continue sharing interesting AI projects that I'm building. So please consider giving me a subscribe if you're interested. Thank you, and I'll see you next time.